let's differentiate between the simple and compounding interest. These are two different ways to where these are two ways our interests are accrued in our financial instruments. However, the more common method is the compounding interest. Okay. Do you remember these two accumulation function? I hope you do. We saw it before. So this one, it is an increasing exponentially, and then this one is increasing linearly. So of course, I think we agreed already that as an investor, we would prefer this method of interest accrual, but as a borrower, of course, we would prefer to pay less interest, right? So as a borrower, we will be preferring this more than the compounding interest. So what's happening in the compounding interest method? So here, interest also earns interest, whereas simple interest, only the principal amount earns interest. Okay, so only the principal amount work to grow more, but here the principal grow more, interest also will grow more. Okay, so if the I is constant throughout time, then our accumulation function in a compounding interest environment is going to be as such: AT is equals to 1 plus I to the power of T. Whereas if the I is constant throughout time in a simple interest environment, the accumulation function will look like this: 1 plus I times T. Okay, so I just want to share here that compound interest term is commonly used to describe this accumulation function lah, where the investment grow in this pattern. It grows exponentially in this pattern where the growth rate is constant throughout time. However, even if the rate varies within our period of investment, the interest rate, the growth rate varies, but we still consider it as a compounding interest. As long as interest earns interest, it is a compounding interest scenario. It doesn't have to look like this pattern to be a compounding interest scenario. It can look like this and still be a compounding interest scenario, as long as interest earns interest. But this is the cleanest, simplest version of the compounding interest scenario. Alright. Also, as I said just now, compounding interest, where interest earns interest, is the most common way interest is accrued in our financial instruments. Simple interest is less common. And also, I want to highlight that if you see, both uses I, right? However, this I are two different animals. It works totally differently. So I really wish they don't use the same notation for these two, but unfortunately it is very common in most books that they use the same notation of I. So I just want to highlight to you so that you don't get confused. Whenever you see I, you have to understand that they are not the same thing between the compound interest and the simple interest. Okay, let's do an exercise to compare the impact of the compounding interest and the simple interest. Okay, we want to find the accumulation value at time 3, basically EV3 of an initial investment of 1,000 when the interest rate is 5% for both. So here the I is 5% and here also the I is 5%. But as I said, this I and this I is not equivalent. Okay, so let's find the A3. So here, as I said, for compounding interest, we will use this formula, right? C times 1 plus I to the power of T. This one is C times 1 plus I T. Okay, so then our AV3 our AV3 becomes 1157, and this one is AV3 is 1150. So as expected, compound interest will give you a higher value, because interest also earns interest, not just the principal. Okay, I want to illustrate to you the power of the compounding interest. Let's say the annual interest is 5%. So it doesn't sound very high, right? 5% per year, it doesn't sound very high. Look at how it compounds. If your starting investment is 100,000, over 10 years, you increase by about 50,000, about 50%. But in the next 10 years, another 10 years, you increase by about how much? Almost 100k, almost. And then here, how much did you increase? From 20 to 30, from 240 to almost 440, so almost 200k. So if you can see, it is the impact of compounding is really drastic in the long term. So that's why savings is important, right? And also, if you can see here, no wonder we need inflation rate, because if not, wealth will exponentially increasing. If our price remain the same without inflation, then we won't be able to cater to all of the demand for goods in the market. Wealth is getting more and more, increasing exponentially, and number of goods wouldn't be increasing exponentially, right? So yeah, it leads to a question of, is this sustainable? But that's a economics question. Okay, let's go to a summary. So the accumulation function shows accumulation value with respect to time t. This is a sample of an amount function. This is accumulation function, this is amount function. And also we're talking about the accumulated value is technically C times the accumulation value factor. Okay, for present value factor is equals to 1 over AVF. And then to get the present value, we take the payment that we want to achieve times the present value factor, or payment over the accumulated value factor. And then compound interest keeps earning interest. Simple interest simple interest, only principal earns interest. And then this is going to be the accumulation function. Okay, so that's all for today. Thank you, and I'll see you in the next video.